afternoon, everyone. It's a pleasure to be here with you. I was planning to introduce myself, but this has been done already, so I will just go quickly. Today, I will introduce to you the role of Agentic AI in our aerial system. I'm from the Technology Innovation Institute, which is a technology institute in Abu Dhabi, which is tailored on autonomous robotic research. Today, as I said, we investigate both the work that we are doing at TI and what is called ServeAI, which is one of our products, where we apply our knowledge on aerial system on single, multiple, and swarm of robots, and we use Agentic AI end-to-end to generate missions down to the level of the drone execution. But let's start from the beginning. This is more or less the reality nowadays. Everyone is talking about Agentic AI. Agentic AI is becoming some kind of buzzwords, but not many are actually understanding the big challenges that this is posing. Because Agentic AI is not a buzzword. Agentic AI is an actual framework. It's a real architecture. LLM, since their introduction, are becoming more and more important, are becoming the core, the backbone of this Agentic AI transformation. And as we merge this with tools, as we merge this with API, memory verification, taxonomies, ontologies, what before was called AI, and now we call classical AI, this becomes a complete new framework. Old autonomy was quite simple. It was a black box. You had your input. You were expecting some output. New autonomy, thanks to Agentic AI, can take your intent, what you want to do, propose a structured plan, and finally execute the plan. And this is really important for us, and it's really important when you apply this into the aerial systems of today. At TII, we have mastered flight, but now we must master the thought. Because the next leap in autonomy is not about having better motors, better sensors. It's about being cognitive. Here we can fly one, multiple drones, swarm of drones, but this is nothing if you don't have control over it. Because today, autonomy at the edge is something that is possible, right? I mean, the hardware has caught up. Edge AI, it's a reality. You can use NVIDIA, Qualcomm, Huawei, you name it. Every kind of chip, you install it on a drone, and you have edge autonomy. This gives you real-time vision, mapping capabilities, decision-making capabilities. And we can say that we are at the edge of solving awareness. And the next frontier for us is understanding. Because yes, autonomy at the edge is possible, but understanding is not perception. If you see something, I can look at all of you. I see a beautiful audience here. I see a stage. I can go outside and look at the bridge. And then I need to understand the context in which the bridge is placed on in order to be able to close the gap and have a real context understanding that I can apply in my real missions. So we need cognitive autonomy for this. But once we understand and we plan and we define the mission, we also need to understand who's defining the mission. Today it's us, it's the operator. I sit in front of my ground control station, I prepare my mission, maybe I do one or two debriefs, 20 minutes, 30 minutes. But then this is a big overload on me, right? And if I'm doing this for one drone, and I have to do this for 10 drones and for 20 drones, the cognitive overload on the operator becomes unsustainable. Because the human today still must specify why these operations matter, why objectives should be pursued, how the assets should coordinate, which constraint, priorities, and rules should apply. This is a gap in our reality, a gap that we need to close by proposing a mission planner, a mission agent that can actually do this for us. But then here we have another risk. How do we trust the decision maker? If it is us, it's a matter of accountability, right? But once we offload this to the AI, how do we trust it? Agentic AI is giving us the tool to go end-to-end and being able to do this. But we still need a framework to be able to trust it. At TII, we're investigating what today is called neurosymbolic AI. Now, neurosymbolic AI is an emerging subfield of AI that we believe can actually solve the trustworthiness problem. It's quite easy if you think about it because it's composed by two words, the neural intuition part and the symbolic reasoning part. By putting these two parts together, you can ground the LLM outputs or the neural outputs to reality by using what, again, before was called classical AI. I'll just give you an example here and a motivation. What neurosymbolic AI is trying to do is to have a deterministic stochasticity. Because agentic AI is able to learn, to adapt, to replan for you, but sometimes it surprises with hallucinations. We used to do this, right? When Wikipedia was out, we were going on Wikipedia and we were never trusting the article at the beginning until we finally built trust on it. Then agentic AI also gives us speed and generalization, but at the cost of predictability and determinism. Here on the bottom, you have a very simple example. I hope that many of you saw the movie that I'm showing here. If not, please get up to date. So we are trying to answer a question. Are the guys in the picture surprised or scared? For those of you that saw this, you know. But I will not spoil for the other. So you can take this one, which is a picture, is a series of pixels. This is an unstructured environment. We can use our neural perception layers, well-structured, deep neural networks. This has been in the field since a while. Do some pattern matching, and most probably the output of this image will be, the guys are 80% scared, and maybe I have a 20% confidence that they are surprised. This because you are lacking the context. You can ground this by using this neurosymbolic framework with knowledge reasoning, ontologies, taxonomies, and classical formal AI, give the context to this one, and finally understand that in that scene, something is happening that is making them surprised, not scared. And this is a simple example. This is a trivial example, but this can be applied everywhere. And it allows us actually to get one agent, make it reliable, make it interpretable, and then finally scale this up to multiple agents. And here, don't be mistaken when I'm talking about agents, I'm talking about physical agents. This is extremely important. Having an explainable AI when you have physical agents that are interacting with the environment, this is something that we are targeting. Agentic AI then can use this, put together all the tools that you have, all the agents, the context, the orchestration, and finally have a foundation that is enabling us to have one single coherent intelligence end-to-end. And as I said, this is what we are trying to do at TII, and this is what we are doing with SIRP. SIRP is a full ecosystem for intelligent drone swarms. It gives digital minds into physical fleets. It's a swarm of robots that can be controlled by one single operator. In our experiments, we had one single operator guiding 22 different drones, fixed-wing, quadcopters, performing different kinds of actions, all with a few clicks and a very low cognitive overload. SIRP is modular, is end-to-end. We have the command and control at the very top level, that is the one that you are interacting with. We have the brain, which is basically your assistant. And then finally, we have our swarm, the physical assets on which you deploy the code, deterministic code that you know what they're going to do, you can predict them, and finally monitor them. Between these, SIRP Officer is our module, Agentic AI module, that allows you from simple queries like perform a scan over a set of assets in this area, and then gives you the entire full mission plan end-to-end. You can actually see this. We set up a live demo right around the corner. Just to give you a bit more of background of what we have, we start with the C2. The C2 has all those agentic AI modules and or classical modules that gives you situational awareness, intel analysis, mission planning. Here you can control every single drone. You can stop, change the mission, or you can simply ask our brain to support you, to help you with the planning. Here you have the example that you will see there if you are willing to join us, where you can drag and drop a few assets that you have, a few targets. You just type or speak with the system, and bam, you have the mission. So your mission profiles are now becoming actual missions that are based on a vocabulary of capabilities that the drones are offering. Now I'm talking about drones, but this is easy to extend. This can work for any kind of robot. And once this is done, you deploy your profile, and you have your swarm flying up. And this is the example I was telling you about before. You can notice that this was Abu Dhabi. It's full desert. It's not like here. And this is it. SERB gives you swarm dominance at your fingertip. In SERB, we have one vision, which is a future where the mission writes itself, and the system is able to execute it safely, intelligently, and at scale. Because we do understand that automation is not the usual automation anymore. The world is moving forward, and we're moving from autonomy to agency. The mission planning is actually becoming a lively system because you don't only plan the mission at the beginning. As you perform your mission with your physical assets, you are getting back information that you can replan, feedback, and then change the plan live. All of this with a few clicks, a very low cognitive overload. And SERB is ready for this evolution. We have the mission, your mission intent becomes structured plans, your plans become actual behavior, and your behavior are used to drive coordinated aerial action. Well, this is it. As I said, we are right around the corner. You are welcome to visit us. You can play with the system. You can see it live in a simulated environment. But the mission that you will generate, you will decide what it will be. This is it. Thank you very much for your attention.